Hi everyone, my name is Sam, and I'm going to be talking about our paper, Affordances of Sketch Notations for Multimodal UI Design and Development Tools. The HCI community has long recognized the potential of Sketch for prototyping user interfaces. It is an expressive and relatively unconstrained medium, making it ideal for ideation and iteration in design. With recent advances in machine learning, we have the opportunity to expand the power of Sketch and to go beyond prototyping and creating tools that enable users to develop interactive software through sketching and other kinds of input. This potential is enabled through data, specifically sketches of user interfaces used to train a vision model to recognize sketched elements and implement them. This makes the set of sketches in the dataset inherently a notation. Users will have to sketch their elements similarly to those in the training dataset to be understood. Creating the most useful and usable sketch-based design tools requires careful consideration of their notations and the larger system designs that work effectively with those notations. If we build datasets of UI sketches and systems that use sketch notations without first understanding how best to create the sketch notations themselves, we risk the future usability of these systems. In order to better understand the affordances and usability implications of sketch notations for UI design and development, we use the Cognitive Dimensions framework to examine possible notations and their systems at two extremes: a closed and contained notation and a maximally open notation. Our first hypothetical system, which we call fixed sketch, uses the ImageClef Drawn UI dataset as its notation. This dataset contains UI sketches where the data producers followed specific rules on how to draw each UI element. This means that the set of sketches in the correct column of this table encompasses the whole notation. In our paper, we discuss in detail each cognitive dimension in relation to this notation and its larger system, but at a high level, we identified that the main benefit of fixed sketch is consistency, which could support collaboration and enable element-based sketch recognition models. However, its rigidity introduces potential for error and limits the design space. For our second system, which we call flexi-sketch, we consider the fact that part of the benefit of sketching is that it allows people to represent whatever they want. So we conducted a study of 21 individuals sketching UIs without any constraints on how sketched elements should look. The data from this study forms our second notation, which we examine to understand the feasibility and trade-offs of enabling a less constrained approach to UI sketching. We found that participants drew elements in many different ways, changing their representations over time and varying the level of detail. Their drawings were highly contextual. For example, spelled out text above squiggly lines together implies a header and a paragraph. They also drew more than just elements, layering additional notations to represent labels and commands. For example, repeat this element 6 times. The flexi-sketch approach enabled participants to sketch according to their intuitions. The notation is dynamic, contextually interpretable, and highly expressive. Models can adapt to this kind of notation by enabling and learning from user correction, eventually specializing to each user's representational styles. To achieve a human-centered approach, we need to develop new sketch understanding methods that are capable of handling heterogeneous and ever-evolving open-ended notations. We recommend that systems support intuitive sketching practices by using the rich available contextual information, by supporting individuals making regular changes to their own personalized notations, by using human-in-the-loop approaches to learn from user corrections of model misunderstandings, and by supporting layered notations, allowing users to represent not just elements, but interactions and annotations. We should also investigate if there are optimal notational middle grounds to help users develop notations between the extreme open and closed-ended notations of this study to balance the expressive power, ease of use, productivity, and computational understandability. We also don't want to limit expressivity to Sketch. We want to be able to combine Sketch with natural language and references to examples, and that is going to require new interaction techniques and models that enable adaptation in response to ever-changing inputs. If you are interested in hearing more about this work, I would love to chat with you at the poster session. Thank you.